All right, let's get started with the rational function unit under our pre-calculus course. For the first question we have, consider the following rational function f, where we have a function or equation which has a degree 5, the maximum power of x is 5 divided by x minus 6. We have to determine this f's end behavior. Now we know that in order to determine the a function's end behavior, we divide the maximum power in the denominator, which is 9x to the power 5, divided by the maximum power in the numerator of the you know of the same degree. So here we have a function or an expression up to x to the power 5, but in the denominator we don't have one, so which means that term is absent, 0 x to the power 5. So then we divide that. So 9 divided by 0 is infinity, or um, this sign. Okay, so as x tends to negative infinity and positive infinity, the function should also tend to infinity. That's the answer. So there we go. This is how it is. So for the next function, we have um, x to the power n and m to the power n. We don't know what that is, where m and n integers, and a, b, c, they are unknown constant. So we don't know any of this, but we know a constant, 14 and negative 7. Which of the following is a possible graph of y equals to fx? So how can we know what that is? Just by seeing the constants. Well, we know that 14 divided by 7 is negative 2. So I should have an intercept at negative 2. So this is the answer. Yep. So you see, the constants tell us the y-intercept. If we divide the first numerator with the denominator, the constants, we get negative 2. And this is where the graph should cross the y-intercept. So here we have negative 2, and none of the other options have it. So this is how we could say that this is the answer. All right. So we have Naira paddled 4.5 kilometers with the current in the same amount of time as it took her to paddle 3 kilometers against the current. So we have a current in this flow, let's say, and this person has paddled 4.5 kilometers with the current in the same amount of time, let that be t, as it took her to paddle 3 kilometers against it. So in the same amount of time, however, when she went from against the current, she was only able to paddle 3 kilometers. So paddle 4.5 kilometers with the current in the same amount of time as it took her to paddle 3 kilometers against the current. Naira paddled at an average rate. Now we can see the speed. Okay, 5 kilometers per hour relative to the water each way. Okay, assume the speed of the current was constant. What is the speed of the current? Okay, so that is the reason relative to the water each way, while she was going in the same direction as current and also against the current. So that's why she got less distance. She was able to paddle less distance when she was traveling to the um, opposite to the current. So we don't know the speed of the current, but we know that it is constant. So let that be v. But we know that speed or velocity equals to distance divided by time. And let's consider this motion when she was going in the same direction. So these the kilometers is 4.5, the same I know, but we also know the time. But as for the speed, it is his 5. Now Naira's 5 kilometer relative to the Wurza plus V, which is the current, because they're in the same direction. From here, we can find an equation of 5 plus Vt equals 4.5. And we're interested in finding the speed of the current. So we will actually make T the subject here, 4.5 divided by 5 plus V. Now, in this opposite direction, we use the same formula, but this time this will be 5 minus V because, they are opposite. The Naira is going against the current. So this will have the distance, which is 3 divided by T. Now we can substitute T here, and we find the equation 5 minus V equals to 3 divided by 4.5 divided by 5 plus V. We just have to solve that and find the value of V. So I will solve it in decimals, but since V is not a variable in decimals, I'll just switch V with X, and that's it. Nothing, uh, nothing else is different. So 5 minus X equals 3 divided by, we have 4.5 divided by 4.5 divided by 5 plus V, so 5 plus X. So we have a value of 1. So this should be 1. There we go. Answer to questions about the following rational multiplications. What is the product in lowest terms? Okay, in order to know this, we have to, what we do is first we work on this fraction here. So we want to factorizing the numerator, and if I take negative 5 constant in the denominator, we have x plus 1. Okay, negative 5, negative 5x, negative 5. And if I want to factorize this thing, x squared plus 8x plus 15. So x squared plus 8x plus 15. Okay, x squared plus 8x plus 15. I get negative 5 and negative 3. That means x plus 5, x plus 3. This is the factor. If negative 5 and negative 3 are the roots, then the factors are x plus 5 and x plus 3. Now, if I want to work on this equation here, I can take 2, I can factor out 2 and I get x plus 5, okay? 2x plus 5 to the 10. And then again factorizing x squared plus 2x plus 1. So x squared plus 2x plus 1. So I get x minus 1. So that means the factor would be x plus 1 whole squared. Since this is a quadratic equation, x squared plus 2x plus 1, I get a root of negative 1. So that means the factorization is x plus 1 whole squared. Now we want to find the product in lowest term, and what values of x must be excluded from the domains of the expressions. These are the values that we don't want such that the denominator becomes 0 or undefined. So if we insert a negative 5 here, negative 5 plus 5 becomes 0. So our answer is this one. And if you have a negative 1 here, this also makes this 0. So we don't want this value here. So negative 1 and negative 5 will be the answer for this. As for the product in lowest terms, we can see that we can cancel out x plus 1 here and 1 here, and we can cancel out x plus 5. So in the numerator we have x plus 3 times x plus 1. So x plus 3 times, we have x plus 1, and in the numerator and the denominator we have negative 5 times 2, which is negative 10. So negative 10, that should be our answer. There we go. We have to subtract. The numerator should be expanded and simplified. The numerator should be either expanded or factorized. Let's factorize this thing. So if I want to take 9 out, so we have x squared negative 4x, right? 9 into 4 is 45. 9 into 5 is 45. Yeah. So this is 5x. So 9x squared negative 5 9 0 45x. Now we have to factorize x squared negative 5x. So x squared negative 5x. If you factorize that, we get 0 and 5. So x minus 5. So that means x minus 5 and x and the 9. Okay, so 0 and 5. So x minus 5 for this one, only x for this one, and the 9 that I have taken common. This should be fine. As for this thing, x squared minus, I can write it x squared minus 5 squared. 25 I can write 5 squared. So a plus b, a minus b, we use that formula. So this is what we get when we factorize it. Now, when we're subtracting, we have to find the LCM, or the lowest common multiple, of these two, which is x minus 5, which is common in both. We also have x plus 5 once here, and the 9x. This is what we write in the denominator. Okay, so x minus 5, and we have x plus 5. Okay, x plus 5 here, x plus 5 here, x plus minus 5 here, and 9x. Okay, now when here we have x minus 5 and 9x. So what is common? Everything except for x plus 5. So we write x plus 5 multiplied by 4 minus, here we have these things, so these things cancel out, and we don't have 9x here, so 9x into 6x. Okay, so rechecking, this thing had this thing, so x plus 5 into 4 and negative 9x, because these things are already common, so cancel out, we have 9x. Okay, now what do you have in above here? We have 4x plus 5 4 is 20, negative 9 into 6 is 54, if I'm not mistaken. 54, 54x squared, and below we have 9x, x minus 5, x plus 5. Okay, so the numerator should be expanded and simplified. I expanded and simplified. This is the most simplified manner. Negative 54x squared, positive 4x, negative 54x squared, positive positive 4x, positive 20, positive 4x, positive 20. Now what do you have in the denominator? We have, the denominator should be either expanded or factorized. We have factorized it. So 9x, x minus 5, x plus 5. 9x into x minus 5. We have x plus 5. So this should be our answer. There we go. At each of the following values of x, select whether h has 0, a vertical asymptote, or a removal discontinuity. In order to do so, we must factorize both the numerator and the denominator. Okay, so this is what we're going to do. We're going to factorize the numerator here and the denominator here. Okay, we have the original equation, so I'll keep it, that one, intact as well here. So if we factorize this thing, what do we get? We get x minus 4. So that is the same as x plus 4 whole squared. You see the same graph, right? So x plus 4 whole square for this one. And for this, we have minus 4 and minus 2. So that means x plus 4 multiplied by x. We have what? Minus 2, right? So x plus 2. X plus 2. There we go. We have the same graph, as you can see. So our factorization is correct. So now, what do we have in the numerator? We have x squared plus 8x. So this thing is congruent to this thing. So we write x plus 4 whole square above, x plus 4 whole squared, and divided by x plus 4 into x plus 2. X plus 4 into x plus 2. Now, we know that x plus 4 gets cancelled out here. So that means when we have a minus 4 here, we still, that will be undefined, but because it gets cancelled out, it will be a removable discontinuity at x negative 4. But when we have x negative 2, then we have vertical asymptote because it is always being undefined. So this will be our answer. There we go. Answer to questions about the following irrational expressions, which what is an equivalent expression in lowest terms. We have to factorize. So if I take out 3 common here, we get x minus 4 because 4 3s are 12, and x squared negative 8x plus 16, x squared negative 8x plus 16. When factored, we get 4. So x minus 4 whole squared. X squared negative 8x plus 16, we get 4. So x minus 4 whole square. And we can cancel out this. So this equivalent expression will be x minus 4 over 3. Let's see. X minus 4 over 3. Now, what values of x must be excluded from the domains of the expressions? That is anything that makes it undefined. So which is 4, positive 4 only. So this is our answer. Answer to questions about the following rational division. What is the quotient in lowest terms, which means we have to divide it? And what are the values of x? Okay, we'll deal that later. First, we're going to find the quotient. So if this thing is divided by this thing, what happens is when we multiply that, it gets flipped. It gets reciprocal. So x plus 1 is comes here, and this thing comes down. So x squared negative 6x negative 7. Let's see. X squared negative 6x negative 7. X squared negative 6x negative 7 is x plus 1 x minus 7. X plus 1 x minus 7. This is 7. X plus 1 x minus 7. Okay, x plus 1 x minus 7. Okay, this is what we get for x squared minus 6x minus 7. And x squared plus 16x plus 64. X squared plus 16x plus 64. We have x plus 8. X plus 8 whole squared. Okay, x squared, x plus 8 whole squared. Now, it has got flipped. Now we want to solve this one first. What values of x must be excluded from the domains of the expressions? Those things that make this undefined. So we have negative 1, positive 7, and negative 8. So everything including negative 1, positive 7, negative 8, we just skip 1. So these are the 3 answers. And what is a quotient? Well, we can cut this one with this. So you have 1 upon x minus 7, x plus 8. 1 upon x minus 7 into x plus 8. There we go. Okay, now for the last question. We have the numerator should be expanded and simplified. The denominator should be either expanded or factorized. Okay, so x squared minus 49. We can write 49 as 7 squared. So x squared minus 7 squared is x plus 7 into x minus 7. And regarding x squared negative 4x negative 21, let's see what it is. X squared negative 4x negative 21 negative 21. This is x plus 3 and x minus 7. So x plus 3 and x plus 3 and x minus 7. Let's write it here. X plus 3 and x minus 7. Because I have positive 7, the minus, and negative means positive. So yeah. So this thing upon 8x plus this thing upon 5. So we have, first of all, we find the LCM, lowest common multiple, which is x plus x minus 7 once, x minus 7 once, x plus 3, and x plus 7. Okay, so this thing For this thing, we have everything except for x plus 3. So x plus 3 and we 8x plus we have everything except for x minus 7, so 5 into x minus 7. Okay, now the denominator should be either expanded or factorized. It is factorized, and the numerator should be expanded and simplified. So we have to expand this. So 8x squared, it is 8x squared um, plus 24x plus 5x negative 7 5 is 35. So we have 8x squared plus 29x, 8x squared, 8x squared plus 29x plus 20. Okay, let's have the fraction first, plus 29x, so 8x squared. 24 plus 5 is 29, minus 35. We have minus 35 upon x plus 3, x plus 7, x minus 7. X plus 3, x plus 7. We have, what is wrong with this? X plus 3, x plus 7, x minus 7. Okay, so this is what we should have. Let's check whether our answer is valid or not. We have this thing. Both should be the same graph. Oops. 8x, x squared negative 449 plus 5 over x squared negative 4x negative 21. 8x squared plus 29x negative. It is not the same. So this thing is correct. X squared negative 4x negative 21 is x plus 3 and x minus 7. X plus x minus 7. When we take LCM, we take x minus 7 once, x plus 7, x minus 3. And for 8x should be multiplied with x plus 3 plus 5 should be multiplied with these things are already present, so x plus 7, x plus 7. Oh, here is the mistake. This is x plus 7, because for 5 we only have x minus 7 here, so this will be x plus 7. So this will be plus 35. Now it should be okay. Let's see. Plus 35. Yep, it is the same now. So that is our answer, and the end of this unit test.